When working with explicit transactions, you have to work with three basic parts. The first is the begin transaction statement. This marks the starting point of an explicit transaction for a connection. This is how you tell SQL Server that you want to explicitly begin a transaction. And so SQL Server is going to lump together all of the statements that occur after this statement into that single transaction. And then you either need to commit or roll back the transaction. If you want to commit the transaction, use the commit transaction statement. So this ends a transaction successfully if no errors occurred, and you have control over determining whether or not, in the face of errors, a transaction should commit or roll back. But if you commit it, all data modifications that the transaction made become a permanent part of the database. Any resources that the transaction held are freed at the end of the transaction. And then the third part is the rollback transaction statement. This essentially erases a transaction in which errors occur. All data that the transaction modified returns to the state it was in at the start of the transaction. And that's the important magic that SQL Server is doing that you need to understand. And then any resources that the transaction held are free at the end of the transaction. So in that sense, commit and rollback are the same, again in the sense that once you execute either of those statements, all locks on resources go away. Now in all three of these, you can use tran instead of transaction, just T-R-A-N. And T-SQL supports a variety of those kinds of shortened names. Be careful. Using them can make your code a little bit harder to read and understand. All right, now with transactions, you can also use nested transactions, which means that you nest a transaction inside other transactions. This usually occurs when a stored procedure that contains transactions executes another stored procedure that has its own transactions. SQL Server always gives precedence to the outer transaction. But if an error occurs at any level, then SQL Server is going to roll back all of the nested transactions. And this behavior exists to protect your data. Without that behavior, if any part of a transaction commits but another part rolls back, your data could be left in an inconsistent state. And then you can use the global @@TranCount function in order to return the number of active transactions for the current connection. So this lets you keep track of where you are within nested transactions, and you can even perform conditional logic based on how deeply you're nested within a transaction hierarchy. Here's a simple example of using @@TranCount within an explicit transaction. So I'm within the Northwind database. I explicitly begin a transaction with the begin transaction statement, and I'm going to attempt to update the employees table. I apparently have a spelling correction to make. And then I can execute code like this. A little bit of a contrived example, but it shows how you can use TranCount in order to see where you are, see if there's an active transaction or not. Okay, so begin the transaction, execute the update. If I'm within a transaction, and I will be at this point, then I'm going to execute some code. I'm going to print a statement that the transaction is active, and then roll it back, and then print another message. So I'll go ahead and execute that, and you can see the messages. The transaction is active, and the transaction is rolled back. And then I read the contents of the employee's file, and as you can see, Devolio has not been changed. That transaction was rolled back. Now, you usually not want to roll back a transaction like this just because one is active. But this sample shows how you can use TranCount to find out how deeply nested you are in transactions and then perform various actions based on that information. Now I want to talk about Transact SQL error handling within a transaction and how to communicate errors back to a client application. Traditional error handling in Transact SQL is pretty cumbersome, especially if you're accustomed to error handling in a modern programming language. But SQL Server 2005 introduced structured error handling using try-catch statements, and then SQL Server 2012 added a throw statement. Now I'm going to explore the basic principles of error handling, which haven't changed in several versions of SQL Server. And then in a different section, I'll talk about try, catch, throw error handling. But you have several options in how you handle any errors that occur within and without transactions. All right, so when you're planning for error handling, the best offense is a good defense. Whatever you can do to prevent runtime errors will simplify the process of handling them when they do occur. Transactions and error handling are most effective within stored procedures. So, to make your transactions more efficient and secure, set default values for all input parameters, validate them, and then exit the stored procedure if the parameters don't pass muster. You want to be proactive with your error handling. Whatever you can do to make your code more robust, letting Transact SQL and SQL Server help prevent errors, is going to lead to more reliable and efficient code. The add@error function returns the error number for the last Transact SQL statement that executed. The function clears and resets on each statement that executes. So as a result, you need to check it immediately after the statement is verified, or save it to a local variable. Otherwise, the error information is lost. The error messages are stored in the sys.messages catalog view. And in that table, it contains the value for the message ID column for that error. That's the message number associated with that particular error. And like other system catalogs, you have access to sys.messages, so you can go in and take a look at all the text for all of the system error messages. Here's some simple code that you can use to access the messages within that sys.messages table. So I'll go ahead and execute that. Take a few seconds to execute. And so what's kind of interesting about this is that it displays the error number as well as the text associated with the error. And I can widen that, and you can see that there's some pretty long, complex error messages. And as you can see, there's also places where SQL Server can substitute parameter values to make the error message provide information about the specific context of that error. Now what's really interesting here is that, as you can see right here, this query returned 231,924 rows. And so this is SQL Server 2012. That's up from 97,000 rows in SQL Server 2008 and 67,000, almost 68,000 rows in SQL Server 2005. So that's quite an increase in the number of error messages. As Microsoft adds new features to SQL Server, they have to add more error messages as more things can go wrong. And so it's just been phenomenal growth in the size of the error messages over time. All right, so let's take a look at a simple example of using basic error handling within Transact SQL. So what this code sample does is it creates a transaction with error handling. It attempts to insert a new record into the customers table. And it does that within the context of a transaction. But this is going to violate a primary key constraint within the customers table. I'm trying to insert a new primary key value that already exists. All right, so what the code does, starts out by declaring an error variable. So I'm going to save the error number in that variable. Then I begin the transaction, and I attempt the invalid insert. And then I need to immediately get the value of that global error function. Remember that this is only going to be available immediately after the statement where the error was raised. So I save that to that variable. And then I have access to it, and I can write additional code. All right, so if the error is 0, then I'm going to commit the transaction. And I can do just a simple commit statement. I don't have to say even commit tran. Otherwise, if there was an error, I'm going to print out the error and then roll back the transaction. So I'll go ahead and execute this code. And as you can see, we got an error that was raised. So it was a violation of the primary key constraint. Cannot insert the duplicate key. And then it printed out the message, the statement has been terminated, and displayed the error number. And I can also get the text of the message and so forth. But that shows a simple example of how you can check for an error and then respond to it in different ways, either by committing or rolling back the transaction. And the sample really underscores the fact that you have control over the explicit transaction and you have responsibility. So once you begin a transaction, you have to either commit or roll it back. The simple error handling that I just showed you really isn't sufficient for transactional stored procedures in a client application. In order to create robust applications, there's a few guidelines you need to follow in order to implement transactions within stored procedures. First thing you need to do is validate input parameters and business rules up front, because that saves time because no failed transactions waste cycles on the server. And then you want to anticipate errors and perform checks before opening the transaction. Errors are expensive, so rely on them for actual runtime errors, not for validation. And then, in general, you want to use the set no count on and return detailed error information to client applications. And using output parameters is a good choice because it's more flexible than raising errors as such. Now, in addition to sending back error information to clients, it's also nice to send general status information about the success or failure of an operation. Every stored procedure that modifies data should return a success-failure code and some kind of message. When you standardize this kind of success-failure pattern, it simplifies client coding and makes it easier to determine the status of server operations and branch conditionally according to what errors occur or don't occur. At a minimum, you should consider creating two output parameters. One, an integer value that indicates success or failure. For example, use 0 for success and an error number, either positive or negative, for failure. And then you can also include an output parameter that's a string with more detailed information. And you can use this additional information in many different ways. For example, in a dialog box direct to the user, or for logging the error, or whatever is appropriate within the context of your applications. The example I'm going to show you now creates a stored procedure that implements an explicit transaction to insert a row into the categories table, and it implements error handling. Okay, so the procedure name is insert category transaction, and it's going to take a couple of parameters that specify the category name and the category ID. So this is the data that's going to be inserted into the table. And then it's also going to include a couple of output parameters that have a return code and a return message. And that's going to be how the stored procedure is going to communicate back to the calling code the success or failure of this stored procedure. Okay. All right, so, and to be clear, I'm supplying a category name, which is an input parameter, and then I'm going to get back the new primary key value as an output parameter. So one input parameter, three output parameters. Okay, I set no count on, and then I declare some working variables. These variables are going to capture the error information, the row count information, the number of rows affected by the insert if it happened, and the scope identity value, which is going to be the new primary key. So those are all declared there, and they're all integers. All right, so to be proactive, now once I'm really in the meat of the stored procedure, I'm going to check to see if category name is null. If it is null, well, that's not a valid value. I can't insert a null value into the categories table. So I'm going to set the return code to 515. That's just a local value that I'm deciding means that the null category name is not allowed. It can be whatever value I want, although I did define the return code as an int, so it has to be a valid integer value. And then in the same select statement, setting the return message equal to null category name is not allowed. And then I immediately return. The nice thing here is that I'm checking for a problem before I even begin the transaction. So I don't have the overhead of beginning a transaction, starting to set locks, and so forth. And then another proactive check that I'm making is that I check to see if that category name already exists. So I'm using a subquery here. So this is going to select category name from the categories table. Again, I'm in the Northwind database, where the category name is equal to the parameter value that was passed into the stored procedure. Then I use the exists keyword. So if any records are returned by this query, then it means that the category name exists. I'm not using any wildcards, so it means that there has to be an exact match within the database. Okay, then I set return code to 2601, which within the context of this application, I've decided means name already exists. And I set the return message to that value. And then immediately return from the stored procedure. Okay, so at this point, we're done doing our proactive checks. We've checked pretty much everything that we can anticipate being an error within the stored procedure. Anything else that goes wrong is going to be an unanticipated error. All right, so the next thing to do is begin the transaction and insert the value. Immediately after I execute that insert statement, I then need to check for the error information. And at the same time, I also grab the row count information. So this is going to be 0 if the insert failed. Otherwise, it should be 1 because I inserted a single row into the table. But this is the important part here. I need to grab that information immediately after executing the statement that could cause an error, because otherwise, if I execute additional statements, then that error information for the insert statement is going to be lost, and I can't get it back. All right, then I check to see if there's an error. If there was an error, which means that the number returned by the error function is non-zero, then I'm going to set the return code to that value and a return message to the transaction rolled back. And then I roll back the transaction and immediately return. Same thing happens even if this is a fairly unlikely scenario, but if no error occurred, yet no rows were inserted, well, something really bad happened. I don't know what it is, but I need to take care of that. So I use the return code 2601, return message insert failed, and also roll back the transaction. Okay, otherwise, if error is equal to 0, in other words, if neither of those two conditions were met, then I'm going to commit the transaction. I'm going to grab the scope identity value because I did have an insert, and this is going to return the last identity value that was inserted on this connection. And I'm going to set the return code to 0, the category ID to identity so I can get that primary key in case the client application needs to immediately use it, and then set the return message. Okay, so that's the stored procedure. Now I'm going to execute this code to create it. And it was successfully created. Always a good thing. All right, now, in order to test the stored procedure, you need to write some code to declare some variables to supply the input parameter values, and then be able to retrieve the values from the output parameters. And then you can inspect the values using a select statement or various other techniques. All right, so here's a variable. It's going to hold the category name, and I assign that to seafood. And then I have category ID, return code, and error message. So these are going to retrieve the values of the output parameters specified within the stored procedure. And then I execute the stored procedure, pass in those variables, specify that the last three are output variables, and then inspect the return values. Okay, now, seafood exists within that categories, so I'm expecting this code to fail, or the insert to fail. And as you can see, I got a null category ID back, return code of 2601, and the return message is name already exists. And again, these are the values returned as output parameters from the stored procedure. All right, I can also test this with a category that doesn't exist. Unfortunately, Northwind apparently doesn't sell vegan products, so there's no existing vegan category. So the only thing different in this code is that I changed the category name to vegan. And I'll execute that. And as you can see, we have a new category ID of 9, return code of 0, which is good news, and a message saying transaction succeeded and the row was added. All right, so this is one of many ways that you can implement simple error handling within a stored procedure. So it works after a fashion. The code produces the desired result of implementing an explicit transaction and returning information to the caller. But the downside is that it involves writing an awful lot of transact SQL code, and the execution path is a little bit difficult to follow. Not too overwhelming in this particular example, but you can imagine if you have more things to check, additional conditionals that you have to include, more execution paths and so forth, the stored procedure can start getting pretty complex. Now you could also write this kind of code with a go-to statement that branches to an error handling block, which could simplify the code. But there's a far better option. Ever since SQL Server 2005, try, catch, throw error handling provides structured exception handling. And we'll talk about that in another section. There's another option that you can use in order to hook into the errors that are built into SQL Server. And you do that using the raise error statement. Using the statement is useful when you want to return an error or informational message to the caller. So here's the syntax for the statement. As usual, the syntax looks a little scarier than the code you write. It really is a fairly simple statement. But what it does is it allows you to raise an error with a message ID, string, or a local variable. One thing that's a bit of an issue using raise error is that the severity and state arguments are required. These don't always make sense, though, for using custom errors or raising different kinds of errors. But the state argument is an arbitrary value, and you can assign any meaning to that you want within your application as you see fit. So don't stress too much over state. Generally, just pass a default value and then not use it. You're usually more interested in the message ID or the string, and sometimes the severity. And I also want to point out that the spelling is a little bit funky. There is, in fact, just one E in raise error, and that's how it's spelled. So somebody just spelled it that way when it was first introduced in SQL Server, and we've lived with it ever since. All right, now the behavior of raise error depends on the severity level of the error. Severity levels of 1 through 10 are considered informational messages, not errors. So if you want to pass back information to the application, you can do that using raise error. Severity levels of 11 through 19 are considered errors. Something went wrong. You have to communicate that information back to the client application. And then severity levels from 19 through 25 indicate fatal errors and have to be logged. Something horribly went wrong, probably something that affects the stability of SQL Server. And you can use those severity levels within your own messages that you raise. There's two different ways that you can use raise error. You can either use it with a user-defined message that's stored in sysmessages, or you can build a message dynamically. So here's an example of using raise error in order to raise a dynamic error when the code detects a duplicate category name. So I'm checking to see, again, I'm doing this kind of proactive checking to check to see whether seafood already exists within the categories table. And if it is, I'm going to raise an error with this custom message, setting the severity level to 16 and the state to 1. So when I execute this, that's the error message that I get. And the nice thing about this is that the format of the error message is the same as a message that was raised by SQL Server itself. You get a message number, and 50,000 is the default because I didn't specify it within raise error, and then the level 16 that I specified within the call to raise error, and state of 1. And then it displays the message that I included within the raise error method. Okay, so you can also use raise error to return user-defined error messages. So this is the syntax for doing that. you need to execute the SP, the system stored procedure, add message. So the required arguments are message number, which is a number greater than 50,000. So SQL Server has reserved greater than 50,000 as the space for user-defined errors. Then you also need to specify the severity. Mentioned that's always a required value. And that can be from 1 to 25. And then you also need to include message text. And that's a string that you define. And then there are additional arguments to specify the language, whether to log the error, and whether the error should replace an existing error with the same number. All right, so here's how you can execute that system stored procedure. So I'm adding message, 50,003, severity level of 16. And then I'm defining this error message. And as you can see, even in custom messages, I can hook into this printf kind of formatting to substitute custom values into these parameters here. Okay, so I'll go ahead and add that to the sys.messages table. And then I can go ahead and raise that error. So when I define the message, I have a session ID, so I'm going to need to grab that value and provide that when I raise the error. And then also a string that is going to be the name of the database. So here's the code that does that. So I'm going to use this SPID variable in order to grab the session ID, and then a name variable in order to grab the current database name. And then I can raise that error, and this is the result. So I execute this, and so I can see that I'm session ID 51, and it caused an error in Northwind because that's the current database context. And then if you need to get rid of the message, you can use the system stored procedure, SP drop message, and execute that, and that custom message is no longer available within the sys.messages table.